Assessing emotions during interactions is arguably one of the most essential social skills that humans have. And in order to assess other people's emotions, we utilize not just information from multiple senses such as hearing, vision, but also from internal states that we carry and presume others to carry based on previous interactions. Not surprisingly, enabling machines to be able to recognize emotions in conversations finds a large number of commercial applications like marketing and management, user interaction, finance, politics, health, and education. The template chosen for this project was deep learning on a public dataset, and the dataset chosen was the MELD dataset, a multimodal multi-party dataset for emotion recognition in conversations published by Poria et al. In 2019. The multimodal nature of the MELD dataset, as well as the level of ambiguity present in its information, is considerable. This data visualization clearly demonstrates that linear or polynomial models would stand little chance in separating the data well enough to build a classifier. Given the challenge at hand, I introduced the HLM12ERC model, a multi-modal emotion classifier capable of processing text, audio, and video based on a model ensemble architecture that fuses these model representations to infer emotions. Early during the prototype development stage, the class imbalance of the MELD dataset that has 47% of its examples labeled as neutral surfaced as the project's first challenge. Cross-entropy weights the error in inferences for all classes in the same way, which can be detrimental for classes with smaller representation. The dice loss function not only outperformed cross-entropy by 2%, but also demonstrated greater ability of learning to predict other classes as well. Model training and evaluation was fully run inside the Google Colab environment, which is very convenient and straightforward to set up, but only persists data until the runtime expires. Additionally, machine learning work requires metric tracking, which is even more important to observe training behavior in terms of convergence and overfitting for non-convex loss functions, such as the dice loss. Weights and biases was used to solve both issues. Finally, multimodal models are invariably expensive with regards to their computational cost. 5 epochs of training on CPU took 27 hours, while 10 epochs took a little over 1 hour on A100 GPUs. Hardware acceleration was therefore vital and used throughout the project. The trainer class provided by Hugging Face's Transformers library was extended and used to orchestrate the training loop's forward, pass, and back propagation logic, chosen for its convenient integration with PyTorch and weights and biases. Each record was read from the file system by the MELD dataset class that uses a pandas data frame with pointers to the audio and image files, as well as the text for utterances. These were batched together by a custom collator class. These batches were consumed by the extended Hugging Face trainer. Bugs in the code offered material risk to the project. 157 automated tests, including unit tests and integration tests, were created and were instrumental in helping ensuring the integrity of the results of experimentation. 30 experiments investigated, compared and fine-tuned the modules that later composed the final model architecture for the HLM12ERC model. The architecture of the model is composed of one feature extractor module for each modality, a feature fusion network followed by a fully connected network responsible for creating the multi-modal representations, which are then mapped into the 7 classes of emotions. The model achieved 55 weight F1 score against the validation split and generalized well over to the test split. The GPT-2 text feature extractor and the multi-headed attention-based fusion network are amongst the modules that have driven the greatest improvement to the target metric. While not at par with the state-of-the-art ERC model SPCL-CL-ERC that performs at 67.7% weighted F1 score on the MELD benchmark, the HLM12ERC accomplished a major achievement at delivering the final model architecture that performed 30% better when compared to its baseline. The robustness of the architecture devised by the experiments run during the development phase was confirmed during the final evaluation. The best model architecture that performed at 55 weighted F1 score on the validation split delivered 57% for the same metric on the test split, demonstrating great ability to generalize over to unseen data. As a result, this project successfully delivered not just against every aim and objective set out during its design phase, but also releases a robust multimodal ERC classifier, conveniently open sourced, that can be used and furthered by the research community for future work.